November 3, 1892, Porte, Indiana. The brass and steel contraption humming in the corner of the telephone exchange would never fully match what European-trained engineers predicted was possible with mechanical switching. An American undertaker's invention. Connecting telephone calls using methods that defied everything telecommunications theory said was necessary for reliable service. Through the clicking and whirring of the Indiana workshop, 75 telephone subscribers were making calls without human operators, something Bell's system managers had declared impossible just months earlier. No operator wages, no sick days, no human judgment calls. Yet Almon Strowger's mechanical switches connected calls with precision that manual operators struggled to match consistently. In European telecommunications theory, human intelligence was irreplaceable. Complex switching required trained operators who could adapt, think, and solve problems in real time. Most telephone systems depended entirely on human intermediaries who controlled every conversation. The Americans were operating with switching philosophy the Europeans had never imagined practical: electromagnetic contacts, two-dimensional mechanical movement, automated call routing, connection speeds that eliminated minutes of waiting for operator assistance. 100 miles south of Chicago, the most decisive telecommunications revolution in industrial history was proving itself. Not through superior training, not through premium equipment, but through mechanical precision that would outlast the telephone companies. In ways European switching theory never imagined possible. By 1881, 49,000 telephones across America required human operators to connect every single call. In the sprawling cities of New York and Chicago, telephone exchanges resembled industrial factories more than communication centers. Women operators, paid 1/4 to 1/2 of men's wages, climbed wooden ladders to reach switchboards that stretched from floor to ceiling. Each operator managed dozens of conversations simultaneously, plugging and unplugging heavy black cords with practiced efficiency. The human bottleneck had become the defining characteristic of American telecommunications. Every telephone call in America passed through the hands of these operators. They knew which subscribers were home, which businesses were closed, and which calls should be connected immediately versus those that could wait. In smaller towns, operators recognized voices instantly and often knew personal details about every subscriber on their exchange. They controlled not just the technical connection between two telephones, but the flow of information itself across entire communities. The system worked, but it carried inherent limitations that grew more obvious as telephone usage expanded. Operators got sick. They made mistakes. They gossiped about private conversations. In busy exchanges, subscribers waited minutes for connections that should have taken seconds. Most importantly, every new subscriber required additional operator capacity, meaning telephone expansion directly translated into higher labor costs. Almon Strowger understood this human bottleneck better than most telephone subscribers. Born in 1839 in Penfield, New York, he had served as a Civil War veteran before establishing himself as an undertaker in small-town Kansas. His methodical approach to business and systematic thinking made him particularly sensitive to inefficiencies in any process. When telephone service arrived in his community, Strowger immediately grasped both its potential and its fundamental weakness. The legend that would follow Strowger through telecommunications history centered on a single grievance that crystallized his determination to eliminate human operators entirely. A competitor's wife worked as the local telephone operator, and according to Strowger's suspicions, she was systematically diverting funeral calls away from his business toward her husband's competing undertaking service. Whether this actually happened became less important than Strowger's reaction to the possibility. He swore publicly to put every last one of them out of a job, referring specifically to telephone operators whose positions gave them unprecedented control over local business communications. This personal motivation drove Strowger to examine the technical challenge that European-trained telecommunications engineers had already declared impossible. Bell system managers educated in established European telecommunications theory argued that human intelligence could never be replaced by mechanical systems when it came to telephone switching. The complexity of managing multiple simultaneous conversations, they insisted, required human judgment that no machine could replicate. European telecommunications philosophy emphasized the superiority of human-mediated service. Bell wanted customers to just pick up the phone and tell the operator what they wanted, rather than perform any switching work themselves. This approach positioned telephone operators not as temporary necessities, but as permanent features that enhance the customer experience. European trained engineers viewed the operator as an intelligent intermediary who could adapt to unusual situations, provide information beyond simple call connections, and maintain the courteous service standards that distinguished premium telecommunications systems. From the Bell system's perspective, mechanical switching represented a step backward in customer service. Why should subscribers be required to perform technical operations when trained operators could handle everything more efficiently? The European model emphasized that telephone service should feel personal and intelligent, not mechanical and impersonal. Bell managers genuinely believed their approach provided superior value that justified higher costs. Strowger's first attempts at mechanical switching seemed to validate European skepticism completely. His initial prototype consisted of a round collar box fitted with straight pins that were supposed to make electrical connections through mechanical movement. The contraption required 6 separate wires per telephone line and demanded that each subscriber maintain a 50-volt battery system. Even Strowger recognized that this design was clearly impractical for commercial deployment. The technical challenges appeared insurmountable. Mechanical switches needed to perform thousands of operations without failure, maintain precise electrical connections across varying environmental conditions, and respond instantly to subscriber commands. European engineers had calculated that the precision required for reliable mechanical switching exceeded the capabilities of available manufacturing techniques. They had good reason to doubt that a Kansas undertaker could solve engineering problems that had stumped telecommunications specialists across multiple countries. Bell system managers pointed to Strowger's crude early prototypes as evidence supporting their position. The mechanical approach required subscribers to learn new procedures, maintained expensive equipment, and introduced additional points of failure into the system. Manual operators, by contrast, provided proven reliability backed by human intelligence that could adapt to unexpected situations. The crushing reality facing Strowger was that his mechanical vision demanded engineering precision that his initial prototypes could not deliver. Every electrical connection had to align perfectly. Every mechanical movement required exact timing. One misaligned contact meant failed calls and frustrated subscribers. The European establishment had legitimate technical grounds for dismissing mechanical switching as an impractical fantasy dreamed up by someone who lacked proper telecommunications training. Yet Strowger's systematic approach to problem solving, developed through years of managing funeral operations and military service, convinced him that human limitations could be engineered out of any system. He had observed how mechanical precision could eliminate human error in other industries. The question was not whether mechanical switching was theoretically possible, but whether American manufacturing capabilities could produce the precision components that European engineers claimed were impossible to build reliably. Strowger's breakthrough emerged from his ability to visualize mechanical movement in 3 dimensions, while European engineers remained trapped in 2-dimensional thinking. The solution that would revolutionize telecommunications required reimagining how electrical contacts could move through space to create connections. Instead of the linear switching mechanisms that European theory predicted, Strowger conceived a system where electromagnets could move a single contact arm in 2 distinct directions simultaneously. The engineering elegance lay in the mathematical precision of the movement pattern. Strowger's switch used electromagnets to lift a contact arm vertically to select one of 10 levels, then rotate it clockwise to choose one of 10 positions within that level. This 2-motion system created exactly 100 possible connections from a single mechanical unit. The first digit dialed by the subscriber raised the arm to the required level. The second digit rotated the arm to the specific contact point. Each movement was controlled by electrical pulses sent directly from the subscriber's telephone, eliminating human operators entirely. European telecommunications engineers had never considered this approach because it violated their fundamental assumption that switching required human intelligence to interpret subscriber intentions. Strowger's system inverted this logic completely. Instead of requiring human interpretation, his mechanical design forced subscribers to communicate their intentions directly to the switching equipment through standardized numerical codes. The machine did not need to think because the system compelled humans to think mechanically. The technical specifications revealed the precision required for commercial success. Each switch bank contained exactly 100 brass contact points arranged in 10 rows of 10 contacts each. The contact arm had to align with mathematical precision to ensure reliable electrical connection. A misalignment of even 1/16 of an inch meant failed calls. The electromagnets controlling arm movement needed to respond to electrical pulses lasting mere milliseconds while maintaining enough power to overcome mechanical resistance and contact corrosion. Recognizing that conventional manufacturing could not achieve the required precision, Strowger made a crucial decision that separated American industrial innovation from European theoretical engineering. He hired a jeweler and helper from Wichita at $5 per day each, wages substantially higher than typical manufacturing work. Jewelers possessed the precision manufacturing skills that telecommunications equipment demanded. They understood how to create mechanical assemblies where every component aligned perfectly and operated smoothly across thousands of cycles. This manufacturing approach represented a distinctly American solution to engineering challenges. Rather than developing elaborate theoretical frameworks to explain why precision manufacturing was impossible, Strowger identified craftsmen who already possessed the required skills and applied their expertise to telecommunications problems. The jewelers brought techniques from watchmaking and precision instrument construction that European telecommunications engineers had never considered relevant to switching equipment. The mechanical components demanded extraordinary durability. Each contact point would cycle millions of times during the switch's operational lifetime. The brass contacts had to maintain electrical conductivity despite repeated mechanical wear, environmental contamination, and oxidation. The electromagnets needed to operate reliably across varying electrical conditions while maintaining precise timing coordination. Every screw, spring, and electrical connection had to function flawlessly because a single component failure meant service interruption for multiple subscribers. By 1900, Strowger's improved switch designs entered commercial deployment in independent telephone exchanges across rural America. The mechanical systems proved their reliability through continuous operation under conditions that frequently challenged human operators. Unlike manual switchboards that required constant operator attention, Strowger switches operated automatically 24 hours daily without supervision, sick days, or wage costs. The operational advantages became immediately obvious to telephone company managers focused on cost efficiency rather than European service theories. Automatic switches eliminated operator wages, the largest operational expense in manual systems. They prevented eavesdropping, a persistent problem with human operators who often listened to private conversations. Most importantly, they connected calls in seconds rather than minutes, dramatically improving subscriber satisfaction while reducing system congestion. By 1904, 4% of independent telephone lines operated with automatic switching equipment. Each installation demonstrated that mechanical precision could exceed human reliability when properly engineered and manufactured. The switches maintained electrical connections more consistently than manual operators who sometimes disconnected calls accidentally or failed to complete connections properly during busy periods. The engineering breakthrough represented more than technical innovation. Strowger's two-motion switching principle established the foundation for all subsequent automatic telephone systems. The mechanical logic of his design proved so fundamentally sound that telecommunications engineers worldwide adopted variations of his approach for decades. Even as technology evolved from mechanical to electronic to digital systems, the basic principle of translating subscriber intentions into systematic switching operations remained unchanged. European telecommunications theory had predicted that mechanical switching would provide inferior service quality compared to human operators. Strowger's switches demonstrated the opposite. Mechanical systems offered superior consistency, reliability, and speed while eliminating the human limitations that European engineers had refused to acknowledge. The precision manufacturing techniques developed for Strowger switches established American leadership in telecommunications equipment that would influence global communications technology for the next century. The mechanical mind that Strowger brought to telecommunications problems represented a distinctly American approach to engineering challenges. Rather than accepting theoretical limitations, he systematically identified solutions through practical experimentation and precision manufacturing. His success proved that complex technical problems could be solved by combining innovative design with superior craftsmanship, establishing principles that would define American industrial leadership across multiple industries. The Bell System's response to Strowger's mechanical breakthrough revealed the philosophical divide that would define telecommunications competition for the next 3 decades. Bell executives, trained in European service traditions, positioned automatic switching not as technological progress, but as a reduction in customer service quality. They argued that subscribers should not be required to perform technical operations that trained professionals could handle more efficiently. Bell's marketing emphasized the superiority of human-mediated service, asking customers why they should do the work themselves when skilled operators could manage everything with greater courtesy and intelligence. This customer service philosophy reflected deeper European telecommunications theory that viewed telephone systems as premium services requiring personal attention rather than mass-market utilities. Bell managers genuinely believed that automatic switching represented a step backward toward impersonal mechanical processes that eliminated the human touch distinguishing quality telecommunications service. They promoted the concept that telephone subscribers deserved intelligent intermediaries who could adapt to unusual situations, provide directory assistance, and maintain the courteous interaction standards that mechanical systems could never replicate. Bell's resistance to automatic switching also protected substantial economic interests built around operator-intensive systems. The company employed thousands of operators across major metropolitan exchanges, representing significant labor investments in training, supervision, and management infrastructure. Automatic switching threatened to eliminate these positions entirely, requiring massive organizational restructuring that would disrupt established operational procedures. Bell executives calculated that maintaining their operator-based system provided competitive advantages that justified higher operational costs. The technical arguments Bell managers advanced against automatic switching carried legitimate weight based on early Strowger installations. Mechanical switches required subscribers to learn new dialing procedures, remember numerical codes instead of simply requesting connections by name, and troubleshoot equipment problems without operator assistance. Bell's manual systems allowed subscribers to reach operators instantly for help with directory information, call, completion assistance, and technical support that automatic equipment could not provide. Bell also emphasized reliability advantages of human operators over mechanical systems. Operators could adapt to unusual circumstances, complete calls despite equipment problems, and provide alternative solutions when standard procedures failed. If automatic switching equipment malfunctioned, entire exchanges could lose service until repair technicians arrived. Manual operators, by contrast, could maintain partial service even during equipment failures by using backup procedures and alternative routing methods. The competitive landscape that emerged from this philosophical divide favored different approaches in different markets. Independent telephone companies serving smaller towns and rural areas adopted automatic switching first, driven by economic necessity rather than service philosophy. These companies lacked the capital to employ large operator staffs and served customers who prioritized basic telephone connectivity over premium service features. For independent operators, automatic switching represented the difference between profitable service and financial failure. Rural and small-town subscribers proved more willing to accept the learning curve associated with automatic dialing in exchange for reliable service at lower costs. They understood that automatic switches meant their local telephone companies could expand service to more customers without proportionally increasing operational expenses. The mechanical systems also eliminated concerns about operator eavesdropping that were particularly sensitive in small communities where operators often knew personal details about every subscriber. Independent telephone companies demonstrated that automatic switching could provide superior service quality when properly implemented. Their mechanical systems connected calls faster than manual operators during peak usage periods and maintained 24-hour availability without the staffing costs required for round-the-clock operator coverage. Subscribers discovered that automatic dialing actually provided more privacy and control over their telephone usage than systems dependent on human intermediaries. The geographic pattern of automatic switching adoption revealed the fundamental economic advantages of Strowger's approach. Independent companies in states like Indiana, Ohio, and Kansas installed automatic equipment while Bell maintained manual systems in major metropolitan markets like New York, Chicago, and Boston. This created a technological divide where country telephone systems often provided more advanced switching capabilities than urban networks serving millions of subscribers. Bell's metropolitan exchanges, despite their sophisticated operator training and premium service standards, struggled with capacity limitations that automatic systems could handle more efficiently. During peak calling periods, subscribers in major cities waited several minutes for operator connections while automatic systems completed calls in seconds. The human bottleneck that had originally motivated Strowger's innovation became increasingly obvious as telephone usage expanded beyond the capacity of manual switching systems. The competitive dynamics intensified as automatic switching technology improved through practical deployment in independent systems. Each installation provided engineering data that allowed manufacturers to refine mechanical designs, eliminate failure points, and reduce manufacturing costs. Independent telephone companies served as testing grounds for innovations that gradually demonstrated the superiority of automatic switching over manual systems. Bell system engineers grudgingly acknowledged that automatic switching offered certain operational advantages, but maintained that these benefits came at the cost of service quality that distinguished premium telecommunication systems. They argued that mechanical efficiency was less important than human intelligence in managing complex communication networks. This position reflected European telecommunications philosophy that emphasized service excellence over operational efficiency. The resistance Bell managers showed toward automatic switching revealed their fundamental misunderstanding of American market preferences. Subscribers increasingly valued speed, privacy, and reliability over personal service that came with higher costs and longer connection times. Automatic switching aligned with American industrial principles that emphasized systematic efficiency over traditional craftsmanship approaches. By 1910, the competitive disadvantages of manual switching had become obvious even to Bell executives, but organizational inertia and sunk costs in operator-intensive infrastructure delayed their adoption of automatic equipment. The company that had dismissed Strowger's innovation as inferior customer service found itself defending an increasingly obsolete approach to telecommunications technology. The mechanical advantage that independent companies had gained through early automatic switching adoption would force Bell to completely restructure their operational philosophy within the next decade. November 3, 1892, marked the moment when Strowger's theoretical innovation faced its most crucial test in the real world of commercial telecommunications. The first Strowger exchange opened in Porte, Indiana, with 75 subscribers and mechanical capacity for 99 connections. The modest installation represented years of engineering refinement compressed into a single mechanical system that would either validate automatic switching or confirm European predictions of inevitable failure. The Porte exchange initially operated with the flawless precision that Strowger had promised skeptical telecommunications engineers. Subscribers lifted their telephone receivers and heard the distinctive mechanical clicking that indicated the switch was ready to receive dialing instructions. They pressed buttons that sent electrical pulses to the switching equipment, watching through the exchange office windows as the mechanical arms moved vertically and horizontally to complete their calls. The system connected subscribers in seconds without human intervention, demonstrating that mechanical intelligence could indeed replace operator judgment. For several weeks, the automatic equipment performed exactly as designed. Local subscribers adapted quickly to the numerical dialing system, appreciating the speed and privacy that mechanical switching provided. Calls connected faster than manual systems could achieve, and subscribers could place calls at any hour without waiting for operator availability. The mechanical precision eliminated human errors that occasionally plagued manual exchanges, and the system operated continuously without breaks for meals, shift changes, or operator fatigue. The engineering triumph, however, concealed mechanical vulnerabilities that only emerged through extended operational testing. The brass contact points that were crucial for electrical connections began showing signs of corrosion that interfered with call completion. The humid Indiana climate caused oxidation that Strowger's workshop testing had not anticipated. Electrical contacts that had functioned perfectly during short-term demonstrations developed resistance that prevented reliable connections after thousands of switching cycles. The electromagnetic systems controlling the mechanical arms proved sensitive to variations in electrical power that manual operators could compensate for instinctively. Power fluctuations caused the arms to move inconsistently, sometimes failing to reach the correct contact points or moving too slowly to complete connections within acceptable time limits. Manual operators would have recognized these problems immediately and adapted their procedures accordingly, but mechanical systems simply malfunctioned without providing alternative solutions. Mechanical wear became apparent as the switching arms performed thousands of operations daily. Components that had operated smoothly during initial testing developed friction that interfered with precise positioning. Springs lost tension, causing arms to move sluggishly or fail to return to neutral positions between calls. The precision manufacturing that jewelers had achieved in Strowger's workshop proved difficult to maintain under continuous operational conditions without regular mechanical adjustments. Bell System executives and European-trained telecommunications engineers seized upon every Porte malfunction as vindication of their theoretical predictions. They pointed out that mechanical systems failed unpredictably, leaving subscribers without service until repair technicians could diagnose and fix specific component problems. Manual operators, they argued, could maintain partial service even during equipment failures by using alternative procedures and creative problem-solving that machines could never replicate. The critics emphasized that automatic switching transferred technical burdens to subscribers who lacked training to troubleshoot system problems. When mechanical switches malfunctioned, subscribers had no recourse except waiting for professional repairs. Manual systems provided immediate human assistance for any connection problems, allowing operators to complete calls using backup procedures or alternative routing methods that maintained service continuity. European telecommunications theory appeared completely validated by the Porte difficulties. Mechanical systems required precision that real-world operational conditions could not sustain reliably. The environmental factors, electrical variations, and continuous mechanical stress that characterized actual telephone exchanges exceeded the capabilities of automatic equipment. Bell managers argued that these failures proved their position that human intelligence was irreplaceable in complex telecommunications operations. The technical problems at Porte also revealed manufacturing limitations that Strowger had not fully appreciated. Components that functioned perfectly in controlled workshop environments failed under the electrical and mechanical stresses of continuous commercial operation. The precision assembly techniques that jewelers brought to switch construction proved insufficient for equipment that needed to operate reliably across varying environmental conditions without constant maintenance attention. Strowger's reputation as an innovative engineer suffered serious damage as reports of Porte switching failures circulated through telecommunications industry publications. Bell System marketing materials highlighted automatic switching problems as evidence that mechanical systems could not provide the reliable service quality that telephone subscribers demanded. European telecommunications journals published technical analyses that questioned whether American manufacturing capabilities could produce equipment sophisticated enough for complex switching operations. The commercial failure at Porte threatened to end automatic switching development before the technology could demonstrate its full potential. Independent telephone companies that had shown interest in Strowger equipment delayed their purchasing decisions pending resolution of the reliability problems that Porte had revealed. Investors who had supported Strowger's innovation began questioning whether automatic switching represented practical telecommunications technology or merely an interesting engineering experiment. The undertaker, who had sworn to eliminate human operators, found himself defending mechanical systems that appeared to validate everything European engineers had predicted about automatic switching limitations. The precision manufacturing, systematic engineering, and innovative design that had created the two-motion switching principle seemed inadequate for the harsh realities of commercial telecommunications service. Manual operators continued handling calls with reliability that mechanical systems had failed to match consistently. The crisis at La Porte represented more than technical setbacks for automatic switching technology. It challenged the fundamental American belief that mechanical precision could solve problems that human intelligence had traditionally managed. European telecommunications philosophy appeared superior to American industrial innovation, and the systematic approach that had driven Strowger's invention seemed insufficient for the complex demands of real-world telephone service. The mechanical failures that plagued the La Porte exchange during its first months of operation provided Bell system executives with ammunition they would use for decades to argue against automatic switching adoption. The engineering solution that rescued Strowger's automatic switching technology emerged from systematic analysis of the La Porte failures rather than abandonment of mechanical principles. Alexander Keith, the technical leader at Automatic Electric Company, approached the contact corrosion problem with the methodical precision that distinguished American manufacturing innovation from European theoretical engineering. Instead of accepting that mechanical contacts would inevitably fail under operational conditions, Keith developed self-cleaning contact systems that turned mechanical wear into an advantage rather than a limitation. The breakthrough came through understanding that contact corrosion occurred when electrical connections remained static, allowing oxidation to build up between contact surfaces. Keith designed contact points that physically wiped against each other during every switching operation, mechanically removing oxidation and maintaining clean electrical connections through continuous use. The more frequently the switches operated, the cleaner the contacts became. This represented a fundamental reversal of European assumptions that mechanical wear necessarily degraded system performance. Keith's self-wiping contacts used precisely angled contact surfaces that scraped against each other as the switching arms moved through their positioning cycles. Each electrical connection was made through a sliding motion that removed oxidation while establishing the circuit path. The mechanical forces that European engineers had viewed as destructive became the cleaning mechanism that maintained long-term reliability. The contacts actually improved their electrical conductivity through repeated operation rather than degrading over time. The manufacturing precision required for self-cleaning contacts exceeded anything previously achieved in telecommunications equipment. Each contact surface needed exact angular relationships to ensure proper wiping action without excessive wear. The brass, alloys used for contact construction, required specific hardness characteristics that would maintain conductivity while providing adequate mechanical durability. Keith's engineers calculated contact pressures, sliding distances, and wear rates with mathematical precision that eliminated guesswork from switching reliability. Under Keith's technical leadership, Automatic Electric introduced additional innovations that addressed every operational problem identified at La Porte. The electromagnetic systems controlling arm movement were redesigned with more powerful magnets and improved mechanical linkages that maintained precise positioning despite power variations. Spring tensions were recalculated to provide consistent arm movement across temperature ranges and mechanical wear patterns that real-world operation would encounter. The company developed the rotary dial telephone in 1896, replacing the button-pressing system that had required subscribers to learn complex pulse-sending procedures. The rotary dial mechanism automatically generated the correct electrical pulses for each number, eliminating subscriber errors that had caused connection failures. This innovation made automatic switching accessible to ordinary telephone users who lacked technical training in electrical pulse generation. The dial mechanism itself represented sophisticated mechanical engineering that coordinated spring-driven rotation with precise electrical pulse generation. As subscribers rotated the dial to each number, a spring-loaded mechanism returned the dial to its starting position while interrupting electrical current in patterns that corresponded to the selected digit. The timing of these interruptions had to match exactly with the switching equipment's electromagnetic response characteristics to ensure reliable call completion. By 1900, step-by-step switching systems incorporating Keith's improvements were deployed worldwide, demonstrating that American mechanical precision could exceed the reliability standards that European telecommunications theory had established. The improved Strowger switches operated continuously for years without the maintenance problems that had plagued the original Laporte installation. Independent telephone companies found that automatic equipment required less maintenance than manual switchboards while providing superior service quality. The global adoption of Strowger switching technology validated the American approach to complex engineering problems through systematic improvement rather than theoretical limitation acceptance. In the United Kingdom, Strowger exchanges provided 83 years of continuous service, far exceeding the operational lifetime of any manual switching system. The mechanical precision that Keith had achieved through manufacturing innovation proved more durable than the human operators that European theory had considered irreplaceable. The commercial success of improved automatic switching equipment forced even Bell system executives to acknowledge the superiority of mechanical systems over manual operations. The company that had dismissed Strowger's innovation as inferior customer service found itself at a competitive disadvantage against independent telephone companies offering faster, more reliable, and less expensive automatic service. Bell did not install its first fully automated office until December 10, 1921, 29 years after Strowger had proven that automatic switching worked commercially. The delay in Bell's adoption of automatic switching cost the company decades of technological leadership and allowed independent telephone companies to establish market positions that threatened Bell's monopolistic control. The European telecommunications philosophy that Bell had embraced proved inferior to American mechanical innovation in every measurable aspect of telephone service quality. Speed, reliability, privacy, and cost efficiency all favored automatic systems over manual operations. Strowger's personal financial outcome from the telecommunications revolution he had initiated revealed the difference between innovation and commercialization in American industrial development. His patents sold for $2.5 million in 1916, equivalent to approximately $50 million in contemporary purchasing power. However, Strowger had sold his interests in the company for only $10,000 in 1898, missing most of the financial benefits from his mechanical breakthrough. The ultimate vindication of Strowger's engineering approach came through the extraordinary operational lifetime of his switching equipment compared to subsequent telecommunications technologies. While modern digital switches require replacement every 3 to 7 years due to software obsolescence and electronic component limitations, Strowger's brass and steel mechanisms operated for decades without updates or major modifications. The last step-by-step switch in the United States was removed in 1999, 107 years after the Laporte installation. The mechanical precision that Keith had achieved through American manufacturing innovation outlasted the telephone companies that originally installed the equipment. In Canada, the final step-by-step switch was replaced in 2002, while the last United Kingdom Strowger exchange was decommissioned on June 23, 1995, at Crawford, Scotland. These mechanical systems had provided reliable telecommunications service longer than any subsequent switching technology, proving that systematic American engineering could create solutions that surpassed theoretical limitations established by European telecommunications philosophy.